Yes, now let's understand the time complexity on binary search. First, I will explain you how the binary search work. Okay. Remember one thing, binary search only work on the sorted array. So binary search only work on sorted array. Okay. So let's take the same example from here. This array is already sorted. Okay. So let's say this array is A. Okay. And again, we are searching 9 here. We are searching 9 in this array. So how binary search work here? So first thing is binary search look for the minimum index plus maximum index. Okay. And then it divide by 2 to find the middle element. Okay. Middle element. So here what will be the middle element? 0 plus 6. So let me give you the indexing here. It is 0. So indexing always start from 0 in array. Okay, this is 4, this is 5, and on the 6 index 12 is present. Okay, so here the minimum index is 0, maximum is 6, right? 6, and whole thing will get divided by 2 to find the middle element. You divide by 2 is 3. So you got the middle element. After the getting the middle element, like here 3, third index is the middle element, and here third index is 8, right? Third index is 8. So now it will look whether, so here third element of the array is 8. Now it will check whether 8 is greater than 9 or it is less than 9, right? In this case, it is greater than 9. Okay. So in this scenario, it will now never look into the initial part of the array. It will only look the number which is greater than 8, the mid element, that is this one. Okay, so you can say our new array will be this. Okay, now here in this case, what will be the, what are the indexes? You can copy it from above. It is 3, 4, 5, 6. So now the minimum index is 3, right? Maximum is 6, 3 plus 6, and whole thing is divided by 2. Sorry, whole thing is divided by 2, that is 6 plus 3 is equal to 9 divided by 2, 4.5, right? So in this case, our mid element will be 5. So here the middle element is 5. And at 5, what is present? On A5, 10 is present, right? Again, it will check whether 10 is greater than 9 or 10 is less than 9. Here 10 is greater than 9, right? So our new array will be this one. Sorry. So our new, it will not look for the number which is greater than the mid element in this case, since it is less than the mid element. So our new array is, now tell me what is the index here? It is 3, 4, 5, right? This will be our new array. This is your new array, and these are the indexes. Again, the minimum is 3, maximum is 5. So 3 plus 5 divided by 2 is 3 plus 8, 5 divided by 2 is 4. So our mid element is 4 here. So what is the value of A4? Mid element is 4, right? So what is present at 4? It is 9, right? So again, it will check whether 9 is greater than 9 or less than 9. It is equal to 9, right? So it will give you the output. Yes, 9 is present at A4. So how many steps it took? 1, 2, and 3, right? And for so in this case, the time complexity is big O log base 2 to the power 2 to the n. So this will be your time complexity. Every time it will basically dividing your array into a two half part. Okay. Now, so now compare the time complexity, like which one is the better here, binary search or linear search? So if you see here, the binary search took 3 steps to solve this problem, right? So number of execution here is 3. Whereas in linear search, it is 1, 2, 3, 4, 5. The same piece of code will execute 5 times to get you the result. And in the binary search, it is 3. So we can say binary search is better approach here in this scenario. So let me approach. Let me plot a graph for you. So I have already done it. So this is not a good graph. Let me give you. Yeah. So this is a graph between size and the time taken. Okay. So in the case of linear search, with increase in size, time is increased linearly. Okay. But in the case of binary search, it is log n. Sorry, it is log n. So you will the graph will come like this. With increase in size, it will not take that much time the linear search is taking. So thank you so much. In the next video, I will do some hands-on this topic using Python. We will see some problem on linear search and binary search. So thank you so much. We'll meet in the next video.